properties of tangents. It says number one says draw a circle and a line. How many ways are there to draw a circle and a line? So you got to be a little creative with this. I came up with 3: circle and a line where they don't intersect, circle and a line where they intersect only once, circle and a line where they intersect twice. Number 2 says, what is the name for a line that intersects a circle twice? That is called a secant. What is the name of the line that intersects circle once? That is called a tangent. All right, so we're working with tangents today. That means we're talking about lines and circles that intersect only once. Kind of a fun reading in terms of the definition. If you Google this, a straight line or plane that touches a curve or curved surface at a point but is extended, does not cross that cross it at that point. Number 2, a completely different line of thought, right? He's gone off on a tangent. And then an adjective of a line or plane touching but not intersecting the curve surface. Now, again, we saw the circle and the line where it intersects only once. But this could be anything. It doesn't have to just be a circle. We're mainly dealing with circles today to keep life exciting. Okay, one of the things that we are going to discover is that when you have a point outside a circle and you draw tangents to these things, you're going to discover, one, that these are going to be the same length, and 2, that the radius is going to be perpendicular. So notice what we have is we end up with 2 identical triangles. Okay. Circle A, they called this A, right? Has a radius of 9, so that's 9 and that's 9. And BC is 12. And 12. That's a 9, 12, right? That's a 3, 4, 5. Multiplied by 3, that's going to be 15 right there. Find AC, we did that. That's 15. Remember, this was a multiple of a 3, 4, 5 Pythagorean triple. Multiplied by 3 is 9, 12, and 15 is how I figured that out. You could use the Pythagorean theorem also. In circle A, EF is 12. AE is 13. And they said AE and BC are in ratio of 1 to 3. AE and BC. So isn't this going to be 3 times 13 or 39? Find the radius of the circle. Now they gave us more information than we needed. That's the interesting part. We didn't need that 39 business, but we'll work with it. We know that if I draw in a radius here, we saw that this was going to be a right angle. That's always going to be the case. This looks like a 5, 12, 13 Pythagorean triple. So the radius has to be 5. You can prove that with the Pythagorean theorem also. All right, some terminology that we're hitting. A tangent line to a circle is perpendicular to the radius of the circle drawn to the point of tangency. There's a tangent line drawn to the center of the circle. That's going to be a perpendicular line. A line through a point on a curve is tangent at the point if and only if it is perpendicular to the radius drawn to the point of tangency. So you end up repeating that. It just flipped things around in terms of how they set it. Okay, interior of a circle, this is interior. Exterior of a circle, that point's going to be exterior. Tangent to the circle, it's going to be right there. That's going to be on the circle. So you could have lines inside, outside, things like that. So if you draw tangents specifically, they're looking at this circle. Here's your radius from the center. Make sure that's center. If I draw just a ray, we still know that that's going to be a right angle if that's tangent. A secant, remember, is just something that intersects more than once, or it's going to intersect twice. Inscribed polygon, we've dealt with these, or we've worked with these. That means it's going to be all 4 points are going to hit the circle. And a circle inscribed in a polygon looks like this. Theoretically, that touches each segment. Okay. All right. We are continuing to look at tangents in the exploration. This is kind of a cool exploration. Let me draw these in, and I'll come back to it. Okay, so they said use the point 12.9 to verify that the radius is 15. That's just asking you to use your Pythagorean theorem, right? This is a 9, 12, or a 3, 4, 5. This is 15. It's a Pythagorean triple. So we know that that has a radius of 15. They're asking you to look also at 12, negative 9, 12, and asking to see what you notice. Now, this is not rocket science here. One of the things I want you to look at is and I'm not going to redraw 12, negative 9. The slope, come on, the slope here is up 9 over 12. 9 over 12 reduces to 3/4. This one here, the slope of this line appears to be similar, only it's going to be a negative slope, and it's going to be a negative 4/3. Notice that because these are perpendicular, their slopes are negative reciprocals of each other. Just something to keep an eye on. More explanation, exploration. They said you need a compass and a straight edge. I don't think we need a compass and a straight edge. I think we just need to be able to play a little bit and see what's going on. They asked us to draw tangents and circles. So if here's a circle, right, you could draw a tangent line like this, and I missed it, didn't I? Like that, like that. How many different situations can you create? Well, if we extend these lines here, couldn't we keep adding circles? And again, where does that hit here? And you can keep doing that for as many circles as you need. Some will intersect, some will not. I didn't do that very well, did I? something like that. Okay. Um, circles, tangent to circles. Again, you're looking at a situation. Whoa, let's try that again. Um, if they're tangent, they're going to be touching in one place. The question is, what about, could a circle be tangent from the inside? Well, that's an interesting way to look at it, and yeah, it can be. You can create multiple circles that are tangent to each other. All right, let's take a look at the examples that we have here. In circle A, the radius is 9 millimeters. AC is 15, BC is 12. Find the area, find the perimeter. So let me draw these in. Okay, so the area, you're just using the area formula, recognizing that this is going to be a right triangle, so your base and height are there. As far as the perimeter, you're adding up all the way around, right? This is 9 and 12 is 21. You multiply that by 2, you get 42 units, whatever those units are. I want you to pay attention to the fact that tangents from a same point are going to be congruent, right? So they're giving us some information here. EF is 12. That means this is also 12. AF is 5. That gives me a radius of 5 here. That means this is 5. That means this is 5. So there's information that comes that they don't even have to give it to you. AE is 13. From here to here is 13. There's a 5, 12, 13 Pythagorean triple. AE to BC is 1 to 3. To BC. So this is 13 times 3, which is 39. Remember, this could be written as x and 3x. As long as you know x equals 13, then you can plug that in. Find BC, round to the nearest whole number. BC is already 39. We've done that. EC along here is going to be the 39 plus 12, or 51 units. Pretty straightforward. We like to call this one the bicycle problem, but what happens is if you draw your tangent, you know that's a right angle. If you draw this tangent, you know that's a right angle. Now, sometimes they don't feel like they are, but they are. They gave us information where they want us to find x, but the problem is this is not a rectangle. If I were to draw in a line perpendicular from here to here, right? So that's perpendicular. That now is x, isn't it? Okay, if this was 3 and this was 5, then this is now going to be 2, right? 5 minus 3 is 2. I now have two sides of a right triangle. 7 and 5 is 12, and we're going to use the Pythagorean theorem. Okay, using the Pythagorean theorem, you come up with 2 root 35. You can plug that into a calculator. I'm not going to do that for you. Good luck and have some fun.